Hey team, today we're going to look at the square root graph, or y equals square root of x, and the transformations of it. It comes from y squared equals x, which is the inverse of a quadratic graph. If you haven't done inverses, no need to stress. All you might be recognizing is that, hey, this looks like a quadratic on its side, and it effectively is because it's the inverse of a quadratic. For those who have done inverses, you'll notice that this is a quadratic reflected about the line y equals x. The key part to a quadratic graph is that we have a positive or negative version. Sorry, not the key part of quadratic. The key part of a square root graph is that we have what could be the positive or the negative of it, with the negative being this lower part down here and the positive being this part up here, and we have our turning point, or what we'll get to call the end point. When we're graphing square root graphs, we're only going to graph one or the other, depending which, or a reflected version of one of these. We're not going to be asked to sketch this. We're not going to be asked to actually sketch y squared equals x that has positive and negative solutions. We'll only be asked to sketch one of the square roots. Now, as a reminder, it's really interesting notationally wise is that we know from this y squared equals x that has a positive and a negative solution. So for example, if x was 16, x equals 16, so we have y squared equals 16. We know that technically y can be positive 4 times 4 is 16, but also y could be negative 4. There's a positive and negative solution, so that if we were using inverse operations to solve y squared equals 16, we would take the square root of both sides, and when you take the square root of both sides, you must put a plus or minus in front of it, because there is two solutions. If you're doing inverse operations, you need to put that plus or minus in front of it. So we end up with, because the square and the square root cancel, we get y squared is equal to plus or minus 4. The confusion arises when people see this, y equals square root 16. They'll think, well, the definition of square root is two numbers that multiply to give you what's inside the square root sign. So it could be 4, or it could also be negative 4. By convention, though, if a square root sign is already written, okay, back here there was no square root sign written. We had to apply it to use inverse operations. But by convention, if it's already written, as it is in this case, the answer is only the positive root. Okay, so in this case, the answer is only 4. So if you have to use a square root sign as part of inverse operations, well, then there is a positive and negative solution to that. If a square root sign is written as it is like there, then by definition we only take the positive root. If we wanted the negative answer in our case, maybe because, I don't know, it was a loss instead of a gain, well, it would actually be written as this y is equal to negative square root 16. So if a square root sign is already written, then we only take by convention the positive answer. If we're using a square root to do inverse operations, well, then we must add that plus or minus. Okay, so going back to our graphs, we're only going to have one or the other. We're not going to be asked to graph both at one time. Right, so the general equation. What is the general equation of square root graph? Well, it's y equals a square root of x minus h, all inside the square root, plus k. And if you want to do a quick pause to take a guess of what a, h, and k does, not really much has changed from everything else we've looked at. So a is a dilation and can also be a reflection. Okay, if we have a negative number there, it becomes reflection. H is the horizontal translation, and K is a vertical translation. Okay. Just like quadratics in turning point form, cubics in point of inflection form, hyperbolus truncus, the H is the opposite sign. It's written as x minus h. So if we had a translation to the right 3 units, it would look like x minus 3. Okay, the sign switches, but the k is positive, so if we had a translation 2 units up, that still reads as positive. Unlike hyperbolas and truncus, square root graph doesn't have any asymptotes. It has an endpoint, but it doesn't have any asymptotes. The horizontal and vertical translations identified by H and K telling us where that endpoint is. By endpoint, I'm talking about that point right there, which is effectively sort of like the turning point of a quadratic. It's easiest to find or visualize that endpoint first and then draw your graph from that. So everything we're going to do is about identifying what our H and K values are. Okay. And then go from there. Cool. So on the axis below, sketch the graph of y equals x plus 1 all square root minus 3, labeling intercepts, endpoint, and point of reference if appropriate. So let's jump into it. So to find the horizontal endpoint, we solve what's in the square root equaling to 0. Okay. Or you also are recognizing that right there is the h value. So let's first off do the full complete way, that the endpoint is when that square root bit is equal to 0. So we have, let x plus 1 equal to 0, we get x is equal to negative 1. Also, instead, if we just are thinking in terms of h, we can see there that that's plus 1. So to be able to write that in the form of x minus h, well, this has to be, h would have to be negative 1. So h is negative 1, which matches that. And we can double check that if we go x minus negative 1, we get x plus 1, which is the form that it's written under the square root. So there's two ways you can do it. After a while, we just get used to looking at the h value, go, oh, it's a 1, switch the sign, so h is technically negative 1. From there, we want to identify k value, okay, which is the constant always added on at the end. Okay, so k is negative 3. So that gives us an endpoint of whatever the x value is, which in this case is negative 1, and k value, which is negative 3. So we can plot that. Negative 1 down to negative 3. There we go. Negative 1, negative 3. There's our endpoint. From here, we have to look at the shape. Now, this is a positive square root. There's no negative sign in front of it. So this is the one that goes up. That's a positive. Okay. So we are going to be going that way. Now, unlike truncus and hyperbola where we can get away with one dot, we've got to be really careful here. Clearly from how I've drawn this, somewhere there's going to be a y-axis intercept and somewhere there's going to be a x-axis intercept. So we need to find those before we actually put our line in. So let's find our intercepts. So x-intercept and our y-intercept. X-intercept, the y-intercept is generally easy. We just let x equal 0. Okay, so let x equal 0, so we get y is equal to square root of 0 plus 1 minus 3, square root of 1 minus 3 equals 1 minus 3 equals negative 2. Okay, so there we go. We have 0 minus 2 as a y-intercept, which is very different to how I drew that before. It's actually quite a bit lower. So great catch already. Find our x-intercept, so we need to let y equal to 0. So we're going to get 0 is equal to square root of x plus 1 minus 3. Take the 3 over, we get 3 is equal to square root of x plus 1. To get rid of the square root, we square both sides, so we're going to square that, square that. So we get, I'm running out of space here, 9 is equal to x plus 1. And then take the 1 from both sides, so we get x is equal to 8. So 1, 2, 3, 4, 5, 6, 7, 8. So it's actually over here somewhere. So terrible me, I've started plotting stuff before I've actually found all values. In this case, we could have adjusted the x-axis scale and said that that was -1, -2, 2, 4, 6, 8. We could have done that, and that would have made it a bit easier. So how about we do that? Since this is digital, I can just get rid of that and say right there is -1, 3. My x-axis intercept there is 8, 0. And then we draw and through. Okay, making sure we're going through. Held there, held there. And that's it. That's our square root graph. We have an endpoint. This is included. Okay, so you want to make sure that is a solid circle. And then technically, unless we have a domain, this keeps going on and on forever. We can put any other positive x value in there, and it keeps going. So you need to make sure you have your arrow there as well. Let's have a look here now, though, at a negative version. We've got -3 square root of x minus 1 plus 3. Same thing, let's identify our h and k values. So our h straight off, we're seeing -1, we've got to switch the sign of that, so h is 1. In this case, k is equal to 3, so we have an endpoint of 1, 3. Now I'm going to be careful because I learnt from the last one, let's not plot this straight away. Let's go about finding some intercepts. So let's find an x-intercept and y-intercept. But actually, we will put a dot just to have a think about it, because of which way this goes. This might tell us that one of these intercepts might not exist. So 1, 3, let's just say 1 and 3. Let's say it is there. Since it's a negative version, it's going to come down this way. So we're thinking about shape, it's coming down. We might realize that y-intercept doesn't actually exist. So if you went and tried to find that, you would run into an issue where you wouldn't be able to actually solve to get that value. And I'll show you that so you can see what it looks like, that if you're trying to find intercept straight away and then you run into an issue like, hold on, I can't do this, you need to think about the shape. So we're going to let x equal 0, so we're going to get y is equal to -3 square root 0 minus 1. Let's make that a bit better. Okay, plus 3. So we get y is equal to -3 square root of -1 plus 3. And hopefully you're starting to see the issue. Okay, unless we use imaginary numbers, there's no real solution to the square root of -1. So you couldn't go any further. You wouldn't be able to actually figure out what that is, and that's because there's no y-intercept. So let's do our x-intercept. So let y equal 0. So we get 0 is equal to -3 square root x minus 1 plus 3. Take the 3 over, -3 x minus 1. We've got the -3 in front here, so we're going to divide both sides by -3. We have to do that before we can get into anything inside the square root. So we get -3 divided by -3 is 1 is equal to square root of x minus 1. We're going to square both sides next in inverse operation, so we get 1 is equal to x minus 1, add the 1, so we get 2 is equal to x. So that initial starting point was 1, 3. It happens our other intercept is 2, 0. And we can delete our rough shape line now. And we can come down and out like that and put our arrow on. If you wanted to, you could find another point of reference down here, but you don't have to. Okay, we've got an endpoint. You always need an endpoint, and then you need one other point of the line to give it shape and relative size / scale. In this case, that's been done by an intercept, so we don't need a point of reference. Same happened back here. We had both intercepts, so again, point of reference if appropriate, not needed. We've got a very good sense of size and scale of our graph. Rightio. So I said before there's these two main types, and let me erase all of this so you can see them again. There was positive and then the negative version. We can also reflect the square root graph about the y-axis. We can flip it over the y-axis, okay? And that happens if we have a negative sign inside the square roots. And let's have a think about why this occurs. Putting the negative in front of the x, what happens if we think of positive values and negative values of x? What happens to them when we put them into a regular graph versus, let's put up a little table of thought. Okay. So I'm calling these regular at the moment, even though there's a negative in front, and I'm calling these the neg ones to have a think about it. So if I put a positive x value in here, well, we can do that. Okay, that's allowed. That's all good. Okay. What happens though if I try and put a negative value in there? Well, I get negative inside a square root, which we know if we're only using real numbers, we can't do. That's not allowed. But it flips when we come and look at these negative versions. Since there's the negative sign there, okay, if I put a negative value, negative of a negative means we end up with a positive, and we can do the square root of it. That's allowed, but we couldn't put a positive in. Put positive 2 in there, negative 2, square root of that, no good. Okay. So that's why it gives the appearance of flipping, okay, reflecting about the y-axis, is because negative values now work and positives don't. Okay, so if there's a negative x, that's we are reflected about the y-axis. If there's a negative in front, okay, that's reflecting about the x-axis, bringing it down. So let's have a go. On the axis below, sketch the graph of y equals square root of 4 minus x minus 1, labeling the intercepts. First thing I'm actually going to do here is this is not in our standard form because we have the 4 before the x. Our standard form, the x is already in first, and it makes it easy to identify h and k's and those sorts of things. So let's rewrite in the standard form. So we have y is equal to 4 minus x minus 1. We can rewrite this as just change the order. As long as we take signs, we're allowed to change the order. Okay, it's negative x plus 4 now, minus 1 outside. So straight away, if I want to think about what's the sort of shape, okay, it's positive in front of the square root, so it means I'm up high over here, but there's a negative in front of the x, so it's going to be out this way. So that's my general shape. So what's h and k? Well, we can read them off. We can also always still let what's under the square root equal to 0 and solve that. That gives us our endpoint, but I can, and let's do that, okay, and we'll see what happens to try and read our h and k. So if we let negative x plus 4 equal to 0, we get negative x is equal to negative 4, and all of a sudden we get x is equal to positive 4. What's the issue? The sign hasn't swapped like normal. So what's going on here? This is where this general form written back here isn't, I guess, the full proper general form. Okay, putting that negative in front opens up to what is a full version, which is this. Okay, this b here is our negative, but the key thing to note is it has to be taken out as a common factor from everything that's inside the square root to actually read this h value like we normally do. Okay. Year 12, we get to the point where this is not only negative, it'll be a number, like we might have to graph. Let's actually get rid of that. X plus 1 plus k. Okay, that's we might be asked to graph that 3 square root of negative 2x plus 1 plus k, and this actually holds true for all of the functions we've looked at. When we start to stick this b in there, we need to take it out as a common factor to be able to read the h. So in our case, this we would want to actually write it as negative 2x minus, taking that -2 out as a common factor, we get this plus k. And we can actually read now that our h value is half in this case. So that's what's going on over here. I would want to write this as y is actually equal to square root of negative, take it out as a common factor. We don't want anything with that x. We don't want any coefficient of the x. And since we're taking the negative out, this actually needs to be written as -4 and then -1 outside. So we could read off our h. H is equal to 4, k is equal to -1. So that's our endpoint. So h is 4, -1. And we know it's coming this way. What that tells us from our shape is that we must have an x-axis intercept and also a y-axis intercept. So let's go about finding those. X int, y int. Let y equals 0 for the x-intercept. So we get 0 is equal to square root. Let's use our -x plus 4 plus 1 version. You could use any form of the equation. That will give you the correct answer. -1 is square root -x plus 4. Square both sides. That -1 becomes positive when we square it. Because -x plus 4. Take 4. We get -3 is equal to -x. Multiply both sides by -1. Or divide both sides by -1. We get 3 is equal to x. Oh, which is where I happen to draw that. So let's label this. That's 4 -1. That is 3, 0. And our y-intercept, we're letting let x equals 0. So we get y is equal to square root 4 minus 0 minus 1. Y is equal to square root 4 minus 1. Y is equal to 2 minus 1 is equal to 1. So there, 0, 1. Our endpoint, and that's the one thing we don't want to do shape-wise with a square root, is you don't want a straight line. You want to start going somewhat vertically, because it is technically an inverse quadratic, which has, all quadratics have a flat bit like that. So technically, all square roots should be flat at this turning point or end point that it's coming out of. So my shape was terrible there. You want to go up and then around, and then put our arrow on the end, and we're done. Here, the negative sign's already been taken out, which is going to make it a little bit easier, but you'll still want to change the order of the x and the 2 just to get used to reading your h and k values. But I'm going to leave this one as an exercise for you to graph. And that's it for this video. Have any questions, as always, put them in the comments below or on Google Classroom. Thanks, and have a good day.